Thank you so much, Yancy, and thank you so much to the organization for the invitation. I feel so blessed and honored to share my little bit to this very important discussion and forum. I must say, I got this very broad topic to talk to, but I thought, let me tap into my expertise and experience as a science education researcher and supervisor, and also in the line of work I am in. So I'm going to focus specifically on STEM education innovations, particularly innovation in teaching STEM subjects, and looking at things that we need to consider in terms of pedagogy and what the implications are for us going forward. So let me just, yes, so I think the best place to start is our key stakeholders. These are the students that are coming into our systems, coming into university where I'm based, but also coming into the schools, and this is the future workforce. And as I read through the literature, they are not talking about a new generation of students, Gen Z or Gen Z, born between 1995 and 2010. And for us, they are already in the schools and approaching high school, and some very soon will be joining also university. So these are really serious implications for how we approach these important clients and what we need to do, because often the case is we talk about students who are underprepared for universities, but my question is, are universities prepared for them? So the questions that I just really want us to ponder on are, how will STEM teachers and teacher educators, those who train teachers, then deal with the characteristics and learning styles of Generation Z? Remember that we are still a large a portion of baby boomers, Generation X, millennials, and in some respects, in some aspects we can relate, we are very different. And how will teaching and learning practices be affected in trying to accommodate this new generation of students? What are the implications for STEM education in our schools and universities? Okay, next slide. So I just thought I could just give a little overview of how this group of students are described. Here, the table that I read from the article by Jonas Dwyer and Popsol, they were referring to millennials, but I could really see striking similarities to Gen Z as well. These are students who are confident, and I like the term that they use here. They say computers are not technology for them. So it's not a surprise. I mean, I have a 5-year-old boy. I buy a brand new cell phone. He already knows it better than I do within a week. So the learning preferences are technology oriented. They like to communicate through electronics, chats, text, and the teaching and learning strategy that is best recommended here with this group of students is to include opportunities for electronic and communication and interaction. And I like the previous presentation that really has looked at how we can use technology, the affordances of technology, to reach out to this group. And they are hopeful optimistics. So reality is no longer real. We're talking about the, virtual reality as opposed to reality as we know it. You can actually immerse them in virtual spaces, and it will not come as a surprise, which also offers us the opportunity to also, where costs are involved and students cannot be taken to a real field experience, we can also tap into the potential and the affordances of virtual reality. And we also talk about 4IR. So they want, you could include opportunities for experiential learning and authentic learning in that sense for them. Inclusive as well, they're very team oriented. They like to stay connected. They don't like delays. In fact, this has been a very big topic at universities where students feel like, lecturers are not responding in time. When they want an answer, they want it now. But the fact that they prefer to work in teams is also a good thing, because it's part of the skills that are required in the workplace. And activities here could include group activities, allowing friends to work together, tapping into each other's strengths as well in completing tasks. They are goal and achievement oriented. And this is where technology comes in again, when we can look at the gaming, how we put gaming as part of the feature of learning, of creating authentic learning experiences for them and providing goals. If you give goals, and this also urges us as educators to start being explicit about the learning outcomes. This is what you should have learned in terms of the skills, in terms of the knowledge, in terms of the values by the end of a course or end of a program. They like that. You give them the goals, you give them the end in mind, and they start and work towards that, very focused. And that's why they get frustrated if there's no order in that sense, where they don't know what they're working towards and whether they've arrived at their goals. Civic-minded, they like experiential activities, and they're respectful, treating others with respect. It's very important to feel that they are being treated with respect. And this is very important because I see now we conduct at the university a survey where we ask students how they experience teaching. And one of the items that they always score higher is that feeling that lecturers are communicating with them with respect. They're treating them with respect. So that is a very important thing that they value. And how we could really address that is building opportunities for community engagement. And that's why community engagement should, not just be seen as an option, but part of the curriculum, providing that holistic curriculum that looks at curricular and co-curricular activities to develop, and to touch on this interest. Yeah, so I took this from one of my colleagues' slides. He spoke about then what does it mean? What is effective teaching then, if you want to cater for this group of students, this new generation of students? Well, the transmission of information and memorizing facts, we have learned as much as it is important, but it is not the ultimate. It's not all there is if we want to prepare students for a work environment that's dynamic and constantly changing. And information is not knowledge. So we can transmit information, but not knowledge. Knowledge has to come with those authentic experiences that we immerse them in, where students get an opportunity to create their own knowledge and understanding and make those connections for themselves. So basically what you teach is not what students understand. And that's why I like this cartoon piece here. If you'll see it, there's two friends talking, and it says, I taught Stripe how to whistle. Stripe is the dog in the picture, and the other friend says, but I don't hear him whistling. And then the other one says, but I said I taught him. I didn't say you learned it. And for most of us, this is what we could say about our students. Yeah. So the thing is, we are, caught in a very difficult position with the COVID. We've seen that the future is unpredictable, is uncertain. So how do we prepare students for an unpredictable, uncertain future? While we can't predict the future, but I believe we can at least prepare them for it by providing them and creating opportunities for them to build on their prior knowledge and develop their skills, to help them to become adaptable and flexible and to evolve when it's necessary to do so. So we need to create those opportunities for them through technology, through our in-person interactions. So class time should be meaningful time where we engage with them. And this is why at the university, we have developed this UP way of teaching. And I believe every university kind of works on this model where we're trying to push for flipped teaching and learning, where we encourage students to take agency, prepare before class, and engage during class and consolidate. And this is a very interesting discussion that we are engaging in nowadays, where we say we were working remotely, teaching remotely, the students are back on campus, and they feel that we should still continue with hybrid teaching and learning. But then the students that's coming back is a very different student who says, I could do it all online and remotely the whole time. So give me a reason why I should be in class. So I think it's very important that we provide support to the lecturing or the teaching staff in terms of what technologies are available that they could use to make class time more meaningful, and what technologies they could use to make after class, the consolidation period, more meaningful as well. And here you can see that listed there are things like inquiry-based learning. I'm going to give an example of one of the teaching approaches we used at the university following an inquiry-based learning or teaching approach. There's so much out there, but I believe it also comes down to the pedagogical content knowledge and the TPAC as well, technological knowledge, where we need to continue strengthening or supporting our teaching staff to help them make the pedagogical reasoning and the choices that they make in terms of tools that they use to make meaningful, teaching experiences more meaningful and engaging. So this is just to give you that, again, to emphasize my point that, that there's 4 paradigms of teaching. You can transmit knowledge, and that's all that you do. But I believe that we need to prepare students for an unpredictable future. Our teaching needs to cut across all the paradigms, all the way from transmission to transcendental, where the aim now is to confront students with real life challenges or even simulated challenges that they have to resolve themselves. So developing that problem solving skills through exposing them to either authentic or virtual environments. So this is an example of a kind of teaching that we did to try and develop, number 1, the carrying out of experiments in a chemistry lab with understanding. And number 2, we realized that with, for example, Bachelor of Science chemistry students, a professional identity often comes or develops once they're at a postgraduate level. But the thing is, we wanted to find out, could we facilitate the process of them already developing a professional identity as chemists very early on? And this is how this project then was born. So the brief that we gave to the students was to say, as a company, again, a simulated context-based approach, we approached the student, we said, we have identified an opportunity for a company, hypothetical company, to synthesize a compound, and we want to distribute it to the market. There are 3 ways of synthesizing this product, but the company wants to be responsible. We require your input, and you would have to experiment and explore different routes of synthesis. And we'd like to assign you the task of evaluating routes to synthesizing this compound, but to an extent where you choose the best route that meets the following criteria. Number 1, it has to be the most environmentally friendly route. So there you see it's that infusion of education for sustainable development goals. And the criteria, again, that the route had to meet was the least technically challenging and the most cost-effective route amongst the 3 possibilities. So we gave them 3 possible ways of synthesizing this compound. And the assessment at the end was they had to work in teams to develop an executive summary, which they would deliver to the hypothetical board, and they would get graded on that. So this was part of a scholarship of teaching and learning project, and it's a real life impact story because it was actually done to revamp from that year how we conducted third-year organic chemistry laboratories, which were initially just recipe-based. Students were just carrying out a recipe instructions and getting out of the lab, but they couldn't quite connect the microscopic and the macroscopic and the symbolic representations in chemistry. So the lecturers wanted to explore something different. And this is where this project came in. We call this the simulated industrial project, and we actually used what you call the jigsaw cooperative learning technique, again, addressing that need by this generation to work in teams. So it had a fairly intricate design. We've published on it. Anyone who's interested, I can just give more details about the journal, but it's the South African Journal of Chemistry, I believe. And so we wanted to create a safe space for skills such as planning, practical investigations, problem solving, communication, and metacognition, reflective skills to be developed. And this was over a 4-week period. So one thing that we had to consider was this would be something very foreign. The students would not be used to this. So you couldn't just pull a rug under them. So what we did is we used a scaffolding approach where we then practical 1, experiment 1 and 2, we gradually reduced the amount of instructions given to the students and the detail. And eventually with the last 4 sessions, we then presented the material or the instructions for synthesizing the compound in a journal type abbreviated manner, where they would have to read the abbreviated procedures and deduce from there very important and key information like amounts, concentrations towards preparing for the lab. So we were actively challenging them to plan for the labs themselves, so that, on the rationale that if you had planned it yourself, working with the team, should anything go wrong, you are also empowered to troubleshoot when things don't go the way you predicted. So it was important, again, that we use an existing tried and tested group work approach, which is the jigsaw approach. As I said, there were 3 ways of getting the compound developed. We had then put them in groups of 3. Each one, we call them home groups. So each one had a different route that they were going to experiment with. But to make sure that they went into details and we provided them sufficient time to prepare themselves, we then developed provided an opportunity for a planning session where they would go from their home groups into specialist groups, work together with students from other home groups, allocated the same synthetic route, and then develop the procedures and a plan of how they would execute the synthesis in the lab. And then they would go back to their home groups at the end of the day to report back and make that meaningful contribution. So just to give you a layout to make sure that it makes sense, because it's quite a lot of information all at once. As I said, the planning, especially, I'm just focusing on the planning session of the 4-day activity. During planning, they came together in home groups, 3 people in a home group, each given a specific way of synthesizing the compound. So they came in, we had given them the detail. They were free to investigate this on their own first, but coming back, they tried to think about whether they had interpreted the task correctly, whether they had a common understanding and they understood their roles. And then the majority of the time during the planning session then was them working in those specialist groups, selecting what apparatus they would need, the setups, reaction scale, reagent quantities, the safety considerations, and so on. And then at the end of the day, they would go back and give feedback. But we also wanted to tie in assessment here as well, where we then challenge them to make predictions based on the specialist group feedback, which route they think would come out meeting the majority of those criteria. Yeah, so, but again, another thing that, as I said, we wanted to develop thinking, reflection, reflective practice. Also in the chemist is very important. So we did not want to leave it to chance that they would think about what they were doing and whether they would review their strategies. So we developed what we called reflective learning strategy questionnaires. These were prompts that were thrown in or intentionally introduced at each point to get them to think about what they were doing and maybe revise if necessary. For example, one of the prompts before they came into the planning session were, what do you understand about the task now that you've read the instructions? If they didn't have an answer for this question, then that would help them to engage the facilitator during the planning and say, wait a minute, all the groups, they're group members. I don't think I understand what is expected of me here. The pre-lab, after working in a group, for instance, they also had to, before going into the specialist groups, they had to answer questions such as, what do you still need clarity on before you go into the specialist groups? And once working in the specialist groups, they would be asked whether they think they've received all the information they need for all the steps, if there's something still that they needed clarity on. And when they went into the end of the day, what is your prediction? What do you think the answer will be? But the reflection did not end there. They spent 2 days in the lab, 6-hour laboratories. So at the end of the first day, we gave them a few prompts as well to think about and say, to what extent have you reached your goal in terms of what you need to contribute in your home group eventually? And just to come back, having reflected on that on day 2, what they could do different, what they thought they will change in day 2. Now, the findings here, what we found is that the collaborative work elicited a lot of discussion. You didn't have to, it wasn't a forced situation where we see students put in groups, they don't know why, what the purpose of the groups were. So even the allocation of roles kind of saw them role and modeling those roles as well. So it also provided opportunities for them to reflect and to organize their explanations and arguments in a way that made sense to their peers and make their thoughts to come out in the open, to be more explicit. And the students felt better prepared for the lab, having actively participated in the planning. The planning, by the way, would have been done by the demis, the demonstrators, or the lecturer, but now you're pushing that responsibility to them. And it was very interesting as I observed them step into the lab, that they often want to sit and get like a mini lecture. That day, they just went straight for their stations to start with the experiment, having invested time in the planning, a very important skill as well that is needed in the workplace. So just to summarize, the technical skills were also developed in the process while developing the softer skills like metacognition and understanding. And they were found to engage with the practical, and the nature of questions that they engaged on with the facilitators, the quality was a little bit different. And the reported practical curriculum, it made a very difficult subject, organic chemistry, 3rd year, a bit more accessible and even popular, because this was the final year of the undergrad degree. Students, some of them changed their minds and they wanted to then continue with honors in chemistry. And it also grew the students' ability in all the desired graduate attributes. And also, as I said, establishing a professional identity in students a bit earlier than we often see. So just want to close with a few recommendations. I think what this teaches us is that nothing is cast in stone. We need to adapt and move with the times. We need to continuously revisit the curriculum and align it with the teacher training. That's very important, because we often want to bring innovation, but we never really look back at how were these teachers trained. We need to have that as well reviewed and revisited and align it to industry as well. We cannot be blind to the fact that eventually that's the destination and we are preparing them for industry. and also societal needs. That's why I said it's not just the knowledge we're looking at, but the values and the skills. Infusion of issues around entrepreneurship, education for sustainable development, 21st century skills, the use and the responsible use of technology, safety and security of chemicals, those very important things that we often feel maybe were not properly or explicitly addressed in our curriculum documents. As for learners, I think we can provide more support in preparing them for university, through pre-university programs that are not, just, when these are done as extracurricular outside of the school hours, you provide the students to also experience the content and the science, the technology, the engineering and the math in a non-threatening way, so that it's not something that they're doing for tests or to progress to the next grade. You have an opportunity in these extracurricular programs to develop, instilling them the interest. And for those who don't follow through and go into a STEM career, at least you would have developed a society or a workforce that is STEM literate. And we also need to capacitate STEM educators, pre and in-service professional development opportunities, exposure, partnerships. There's a lot that's out there. I mean, I came across the US Embassy as an opportunity for teachers to go on exchange programs to the US and go and visit and have a broadened exposure to all the opportunities that are there that it could bring to enhance their practice. And STEM teacher education, again, I think as teacher educators, we need to model the teaching that we wish to see in the classrooms. I mean, when I was still training teachers, I used to stand and just do PowerPoint presentations. And to my surprise, when I went to assess my students during teaching practice in the schools, they were also doing presentations. And that made me introspect and think, but they're doing what they saw me doing. So I had to change my approach and model what I wish to see them emulate in the classrooms. And I think that can get us a bit far. In terms of STEM education, I think we need to experiment with different approaches of teaching. Inquiry-based teaching can help you, for example, this POGLE, process-oriented guided inquiry learning. It's another approach that's been published on where you do not compromise the touching on all the important topics that are required by the curriculum, but at the same time, you are developing other skills. And I think we need to start experimenting and using those. Get the students self-regulated, having a growth mindset, and also systems thinking, knowing that a solution, we can't come up with a simple solution to a complex problem. Getting them thinking about at the bigger picture already at school level in terms of the solutions, because these will be our future decision makers. Yeah, I will just end it there. Thank you so much for this opportunity.